Good morning, everyone. So let us look into the structure of diborane in today's class. So if you look at the molecular formula of diborane, it is nothing but B2H6. So it can be thought of as a dimer which consists of two BH3 molecules. So we now have to find out the way in which this two BH3 units are kind of clustered together to form the diborane. As I told you in previous classes, whenever a molecule is having electron deficiency, they try to form cluster compounds to compensate their electron deficiency. So that is what is happening here. Two BH3 molecules, both are electron deficient. So they are trying to compensate by forming a dimer. Now let us look at what is the nature of the dimer that is formed. So if we look at we will use here the valence bond theory to try to find out how these molecules are, like how the structure is happening. So if we look at this molecule, if we write the outer electronic or the valence electron, valence shell electronic configuration of boron in their ground state, we find that the configuration is something like this. Now, for forming the bond, according to valence bond theory, the paired electrons need to be unpaired. Only then it will have three unpaired electrons for the formation of bonds with the three hydrogen atom. So accordingly, in the excited state, this paired electron would be excited to the empty orbital. So we have this configuration. So according to this, we consider hybridization that is possible is sp2, that is 1s and 2p orbitals. So we have a hybridized state where we have an three sp2 hybrid orbitals and one unhybridized p orbital that is empty and remaining as such. So when the BH3 molecule is formed, what happens? You will have the pairing up with the electrons coming from the hydrogen. So these blue electrons are the electrons that are coming from the hydrogen, the 1s orbital of the hydrogen. So these electrons pair up to form the three covalent bonds with the hydrogen. So if we look at just the BH3 molecule, we find that it should have a hybridization, that is sp2. So the structure should be trigonal planar with an unhybridized p orbital kind of perpendicular to the plane of the triangle. So here it is not when the actual structure was seen, the structure was something like if we consider the boron atom, around this boron atom, there is a kind of arrangement so that this looks like a tetrahedral arrangement. So when the structure of diborane was determined, it was found that it is not the sp2 hybridization, but rather a sp3 hybridization that is happening at the central boron atom. If that is the case, how that is going to happen? So when we look into this in detail, as I told you, for getting rid of this electron deficiency, they form cluster compounds. So that means these two BH3 molecules somehow share between each other so that they can compensate for the electron deficiency that is arising out of the empty 2p orbit. So how does they do that? So if we consider these two BH3 molecules, there is empty 2p orbital in both these BH3 molecules. What happens is that one of the bonding electrons, okay, they kind of partially fill up the empty orbital on the adjacent BH3. Similarly, this any one of the paired electron or the bonding electron kind of is donated to the empty orbital of the adjacent BH3 molecule. So when this happens, if you now see the hybridization changes from sp2 to sp3 hybridization. And that is how the hybridization in the actual diborane is not sp2 but rather sp3. So if we now look at this structure, what you find is that this boron is surrounded by three covalent bonds, which is the normal two center, two electron bond. Okay, so each of this boron atom is surrounded by them. Now, what we find here is this particular bonding is kind of a bridged bonding, that is a bridging that is happening between these two boron atoms. So if we consider this as the covalent bond that is attached to this boron atom, this bonding electron kind of get transferred to the empty p orbital of one of this particular boron atom. Thereby this bonding electron is now kind of oscillating between these two boron atoms. So now if you consider the nature of this particular bond or this bridged bond, or we can say it is a hydrogen bridge bond, it is like a three center. There are three centers here and the number of electrons is only 2 electrons. So it is a three center 2 electron bond. So in the same way, this particular bonding electron is kind of oscillating between these two boron atoms. So there are two three center 2 electron bond. However, there are how many 2 center 3 electron bond? There are 4 2 center 2 electron bonds that are present. So this particular, there are two 3 center 2 electron bond and there are 4 2 center normal 2 center 2 electron bond. So this is how the bonding is happening in a diborane system. Now, if you look at the bonding electron, it is having a shape something like this that is drawn in here. It looks like a shape of a banana. So molecular orbital diagram or the molecular orbital picture, since it looks like the shape of a banana, this particular bond is also called as banana bond. Now, if you ask me the strength of a 3 center 2 electron bond versus a 2 center 2 electron bond, obviously 2 center 2 electron bond would be more stronger because it is kind of filled or completely filled kind of a bonding system. However, this is an electron deficient system. So two electrons are kind of shared between three atoms. Usually two electrons form bond between two atoms. So here, since two electrons are forming bond between three atoms, it is still, though it is forming the cluster compounds, though it is taking care of the electron deficiency to a partial extent, still this is a very electron deficient system. And this bond is kind of a weak bond because it is kind of not the usual two center 2 electron bond. So this is how bonding happens in the diborane. So hope you understood this particular thing, and let us try to learn more about the various other compounds of boron in the coming class. Thank you very much.